Hello and welcome to video number 6 in our series of evolving network configuration videos. My name's Kevin Large and I'll be your instructor for this video. The purpose of the video today will be to configure a remote access VPN. So we'll be configuring a remote user physical connection. To do this we'll be using a DSL modem and a cloud, two components that we haven't used so far. We'll be configuring AAA, Authentication, Authorization and Accounting. The bulk of the work will be configuring the remote access VPN, and there's going to be a lot of commands to do that. And then finally we'll test the VPN. So moving on to the network. This network will look quite familiar by now. What we've got is we've got the inside of the network on the 172.16.10.0 subnet with a /23 mask. We have an internet connection, we have a remote office out here. Off to the right hand side we've got a corporate intranet, we've got some wireless connectivity. But the aim today will be to create a remote access user out on the internet. And this user will be coming in through a DSL modem. So let's put the remote access user's PC onto the network, and we'll select a DSL modem, which is under WAN emulation, wide area network emulation. DSL modem, third one across from the left hand side. And we'll also select a cloud while we're here, so we'll go for the generic cloud. First one on the left hand side. Okay, just tidy the screen up slightly. Put our modem over here and a remote user just over there somewhere. Okay, let's just indicate what we're actually doing here. Just going to make the network look a little bit more clear as to what's going on. So what we actually have is we have another connection coming in from the internet over here. Okay. Now how do we wire this up? Well, we're going to use copper straight through cable to go from the PC, fast Ethernet 0, into the DSL modem, the Ethernet port on the DSL modem. You can see the RJ45 shaped picture by port 1, and then we'll come out of the other side of the DSL modem. Just 1 second, and to do that we'll use the phone connection, and the phone connection is a dotted line in the shape of a lightning strike. Okay, so we'll come out of the modem port on the DSL modem, port 0, and we'll go into let's say modem port 4 on the cloud. And then we'll come out of the cloud using another Ethernet cable. We'll come out of Ethernet, it's known as Ethernet 6 on the cloud, and we'll go down into fast Ethernet 00 on our company's edge router. Okay, so this is going to give us some form of internet connectivity now through a telephone connection using the DSL modem. Okay. We need to configure the DSL modem first, so we'll click on the DSL modem. Actually no, the DSL modem doesn't require any configuration, but it's useful to look at. What we've got is we've got the RJ11 phone plug, we've got the RJ45 network plug. It's switched on, so everything's good. There really isn't any configuration required on the DSL modem. Where we do need a configuration is on the cloud. So we'll click on the cloud, and we'll go to the config tab. We'll come down to DSL, digital subscriber line, and let's see, we're coming in on modem 4, which is good because that's highlighted, and we're going out on Ethernet 6, which is also good because that's already highlighted. So we'll just add that modem 4 to Ethernet 6. Right, let's just double check that that was correct. Hover over the little bulb. Let's see, modem 4 and Ethernet 6. Excellent. Okay, so just to recap on that one, it's under the config tab, DSL. You want to select modem 4 to Ethernet 6 and click add. Okay. Now let's get this show on the road. We'll go into our edge router. I'll log in as the user Joe because Joe has privilege 15 access. Okay, there's our message of the day banner. Joe with Joe's password of network 4321. Okay, and we're already in privileged exec mode. What I'm going to do is I'm just going to do a quick show run. We've got a considerable amount of configuration on here already. DHCP pools, sub interfaces, default routes, access lists, all kinds of bits and pieces going on here. What I was looking for, I was just interested to see the exact timeout on the console port, 1 minute and 30 seconds. I'm going to change that because otherwise it's going to become a bit of a pain if it's going to keep logging me out after 1 minute and 30 seconds of non-use on the console port. So I'm just going to type in, actually just set the exact timeout to, hold on 1 second, get into line console first, line console 0, followed by exact timeout, set it to 10 minutes, that's better, it's just going to make things a bit more convenient. Control Z to come out of line configuration mode all the way back to privilege mode, and now we can get going. Let's see, I better put some IP address in on here, so let's make this internet connection 72.44.20.0 on a /28 mask. How's that? /28 mask. Right, with the /28 mask we've got 32 bits in an IP address, subtract 28 is 4. So we have 4 zeros left over, 2 to the power of 4 is 16, so there's 16 addresses, which range from 0 to 15. 0 is their network address, 15 is their broadcast address, so the highest usable address, which will be a default gateway, will be .14. Okay, so there we go. We'll have .14 on the router. I'm actually going to set up DHCP, I think, to do this. Yeah, why not? Okay, back into the router. Configure terminal. Set interface fast Ethernet 01 to connection to the cloud with an IP address of 72.44.20.14. The /28 mask, that would be 255, 255, 255, that's 24 bits, plus the first 4 bits in the 4th octet, 240. Okay. By the way, Packet Tracer will always tell you if you're tapping in a network address or a broadcast address. If I change that to 15, which would be the broadcast address, it gives me the bad mask error. So you can always tell quite easily. If you put in a network or broadcast address, the router will inform you. We'll do a no shutdown, bring the interface up. We now have green lights. Little console message popping up to tell us that the interface has changed state to up. We'll do an exit. We'll set up an IP DHCP pool for the modem connection. IP DHCP pool, we'll call that remote pool. Nice imaginative name. Okay, so IP DHCP pool, remote pool. We'll set the network to 72.44.20.0 with a /28 mask. We'll set our default gateway to 72.44.20.14. 72.44.20.14, highest usable address in the subnet. That's looking good. That's looking good. Let's put the DNS server on there as well, why not? DNS server was, that's a very good question. Let's hover over it. 10.10.10.1. Okay. Control Z, WR. Let's see if this works. We'll go into the PC, desktop, IP configuration, tell it to get an IP address using DHCP. And it has got an IP address of 72.44.21, the first available IP address in our DHCP pool. It's got the correct subnet mask, 255.255.255.240/28. Also has a default gateway of 72.44.20.14 and our DNS server. So that's looking good. Right. Okay. Now, next step. Now we start getting rather complicated because now we need to configure the actual VPN itself. And here we go. So first thing we need to do is turn on AAA, Authentication, Authorization and Accounting. And we do that by typing in the command AAA new model, which is helpful if you type configure terminal first. It's getting global configuration mode, AAA new model. Okay. Now we need to create a AAA authentication login group, so a login user. So let's have a little look. We'll go AAA authentication. You can see what we've got there. For logins, the question mark is such a useful thing to use, and we will give the group a name. If you want to see what comes next, it just says Word, so we'll give the group a name of remote. Remote will tie a lot of things together on this configuration, and we can follow that by use local username authentication. So this will tie back to a local username and password database that you set up with username password or username secret. So local. Okay, we also need to set up a group network login, so AAA, this is for authorization network. Again, we use the word remote, and we'll tie that back to the local username and password database as well. Okay, so there's two AAA commands gone in. Next, we'll create a user in that local username password database. Standard way, done it many times before. We'll call the user VPN, and we'll give them a secret password of super secure. Okay, username VPN, case sensitive in capitals, secret password super secure. Okay, and of course this is what we mean when we say AAA authorization network local. It means it's going to refer back to the local username and password database. Okay. Now for the actual configuration of the VPN itself. First things first, we'll set up what's known as ISACAMP, or Internet Security Association Key Management Protocol, ISACAMP policy for Phase 1 negotiations. So here we go. Very long command, crypto ISACAMP policy. Now we just put a number in here. I don't like to start at 1 if I can help it. I'm just going to put 10. It gives me plenty of leeway. I can put numbers in front or behind in that case. So we're now in crypto ISACAMP policy configuration mode. We can set the encryption to, I'll use the advanced encryption standard AES, and we've got 3 key strengths. We've got 128, 192 and 256-bit key. I'll put a 256-bit key on. AES is a symmetrical encryption. It's extremely strong. A 256-bit symmetrical key. What we're talking about here is, when I say symmetrical encryption, it just basically means it uses the same key to encrypt and decrypt, as opposed to asymmetric encryption, which you have 2 keys. You have a public and a private key. You encrypt with a public key, for instance, can only be decrypted with a private key. Symmetric encryption is very fast, but the problem is, of course, getting the shared key across to the other side, which is the issue. Normally what you'll do is you use asymmetric encryption to send the shared key across, and then once the shared key's on the other side you can switch back to symmetric encryption, which is a lot quicker and not so taxing on your processor and memory. So we've got the encryption set up. We also need to set up the integrity checking mechanism, the hashing. We've got two choices there, MD5 or SHA. So what we'll do is we'll use MD5. SHA is actually slightly stronger, but we'll set the authentication, which we'll set to pre-shared key. We'll set what's known as the Diffie-Hellman group to group 2, and we'll set a key lifetime of 21,600. That's in seconds. It's 21,600 seconds. Okay, that's it. That's IKE Phase 1, Internet Security Association Key Management Protocol, ISACAMP Phase 1 done. We'll exit from there and we'll move on to do... Let's set up our group. We'll set up a group, a crypto ISACAMP group now. So here we go. Pretty much all the commands will start with crypto ISACAMP client configuration group, and we called that remote. You can see where remote's tying everything in now. We'll set a key, and we'll set the key to be Cisco, all in capitals. And we'll set a pool. Now what is the pool? The pool is basically the pool of addresses, IP addresses that are handed out to the VPN clients when they actually connect. And we'll call the pool my pool. Okay, that's done. I'll move on to IKE Phase 2. Again, we'll start with crypto. Only this time we'll type crypto IPSec and we'll set a transform set. We'll call this my set. And we'll set ESP AES, that's the encapsulating security payload, advanced encryption standard. And we'll use the 256-bit key. We'll set a hashing, encapsulating security payload, MD5, HMAC. That's good. So that's IKE Phase 2 sorted out. We're getting close now. We now need to create what's known as a dynamic map. So again, crypto dynamic map. We'll give that a name. I'll call it dynmap. And the sequence number we'll set to 10. Sequence number I just like to set to 10 as before, so it gives me a little leeway either side of the number if I need to slot anything else in front or behind. We need to tie this into a transform set, so we set a transform set which was called my set. And we'll set up reverse route injection. Okay, reverse route injection is really the ability to insert a static route in the routing process for the networks and hosts protected by the remote tunnel endpoint. Okay, we'll exit from the dynamic map. And we're getting there now. We need to create the actual crypto map itself now. We'll put the crypto map commands in. So crypto map, we'll call the crypto map, let's call it client underscore map. Crypto map client map, and the first thing we want to do, let's do a client authentication list. And our client authentication list was, you guessed it, it's just up the top here. How far have we got to go up to find it? Remote. Okay. We'll use the up arrow because just about everything starts with crypto map, client map. We'll set a Internet Security Association Key Management Protocol authorization list to, you guessed it, remote, to tie it in with the AAA up top there. We'll set a crypto map. I could use the up arrow there, but I've started, so I'll finish, as somebody quite famous used to say on the television. Crypto map, client, now, client configuration, address, what have we got? Respond. So this will respond to network address requests from the client. Let's tell it to respond. Okay, and last part of this section, we'll use the up arrow. Crypto map, client map, sequence number 10, IPSec, ISACAMP, tie that in with a dynamic map, dynmap. You can see how different sections tie in with other sections. So this is tying a dynamic map into a crypto map. And in a moment, we'll apply the crypto map to the fast Ethernet 0.1 interface, the interface that the VPN is coming in through on the diagram. And believe it or not, that's almost done. One thing I have almost missed doing is creating the pool. A little bit further up here, we actually had a pool created called My Pool. Well, it wasn't actually created, but we were referencing a pool called My Pool. Now we need to create that pool. So, how do we create an IP pool? IP local pool. Right, IP local pool. That's better. And we called it My Pool. And this will contain the IP addresses that will be handed out to the VPN clients. Now we want to hand out what IP addresses. Let's have a look at a diagram. Obviously it's got to be an IP address on the inside of the network here. And now this remote user is a salesman. So we really want to hand out an IP address in the sales VLAN. The subnet 172.16.10.0/24. But I don't really want it to overlap with anything that's coming off the DHCP pool, so I'm going to hand out a pretty high IP address. 172.16.10, let's see, 172.16.10. We'll start at 150, and we'll go up to 172.16.10.200. That looks good. 50 addresses for the VPN users, starting at 150. So the first address that should be handed out should be 172.16.10.150. That's looking good. Believe it or not, there's only one more command remaining now. That's to go into our interface, fast Ethernet 0.10, sorry, 0.1, and apply the crypto map. Crypto map, and the crypto map was called, you can see it right there, client map. Client underscore map. Aha! Good. I was hoping to see that. Got a little console message popping up. Crypto ISACAMP on off status. ISACAMP is on. Excellent. We'll do a Control Z and a WR to save the configuration. At this point, just quickly run a couple of commands. Show crypto ISACAMP security associations. Show crypto ISACAMP SA. And we do have the headings up there for the destination, the source, the state, but we can see no information underneath, which is not surprising because the VPN isn't actually up yet. What we should see when the VPN goes live is active written there. And we'll do show crypto IPSec SA. These two commands are without doubt two of the most important commands you could possibly have for checking VPNs. Again, no security associations found, not surprising because we haven't connected in and created the VPN yet. The VPN only is created when the client tries to connect in. So without further ado, let's do exactly that. Okay, so let's have a quick look and see how our IP configuration looks at the moment. I'll go into the client, the VPN client PC, and I'll do an ipconfig /all. And you can see our IP address 72.44.21/28 mask, default gateway 72.44.20.114. I'm just going to try pinging that just to make sure we can see it. 72.44.20.14. Yep, looking good. We got anything else up there? No. What we should see when the VPN connects, we should actually see a tunnel interface appear under IP config /all. It's not there yet. Yep, definitely pinging okay. No tunnel interface at the moment. Let's connect the VPN. Testing phase. Okay. Into PC. The remote user PC out on the internet there. We select the VPN client. Click on the VPN client and start filling in information. Now our group name was remote. Our key, a group key, was Cisco, all in capitals. The host IP address is going to be the interface on the router there. That's going to be the tunnel endpoint, because the tunnel protects you on the internet. Once it gets on the other side of the router, you're on your own internal network. You don't need the VPN there. The tunnel is purely to protect you in the bad world of the internet out there. So the tunnel actually runs between the PC and the fast Ethernet 01 interface on the router here. So this is our endpoint for the VPN. 72.44.20.14. 72.44.20.14. Aha. Too many dots. That's better. And now we need a username and a password. Now VPN was a username, and our password should have been super secure. Now comes the moment of truth. We're going to do a connection. Yes, that's precisely what we wanted to see. VPN is connected. Okay. And look at the IP address that we were given, 172.16.10.130. The first address available in our IP local pool. If we go to the command prompt, and we do the ipconfig /all, we have a tunnel interface. This is the local endpoint of the tunnel, 172.16.10.150. It's been given an address in the sales VLAN on the inside of our network. To all intents and purposes, this PC appears to be, would believe that it's on the local area network. Okay. Let's see if we can try something here. Let's go to the router, see what we've got on the router. That's the wrong router, that's the ISP router. This is the one we want. Okay, let's run those two commands again. Show crypto ISACAMP SA for the security associations, and there we go. From the router's perspective, the remote endpoint of the tunnel is 72.44.21. Its local endpoint is its own fast Ethernet 01 interface, 72.44.20.14, and you can see we have an active tunnel. If we do the show crypto IPSec SA, lots of information. A crypto map is known as client map. A local address on the router, 72.44.20.14. The peer, 72.44.21. It's the PC at the other end of the tunnel. We can see that there are no packets encrypted and no packets decrypted, but we can soon fix that. Right. Let's fire a little ping through. So what should we do? We'll ping from the PC up here to the server over here. 72.16.11.97. (172.16.11.97). is when you worry. There's a big pause there as the VPN comes up. We've got a packet dropped there as well, but we do have 3 replies. So let's have a quick look. Show crypto IPSec SA. See if we've got any packets encrypted and decrypted. And yes, packets encrypted 3, packets decrypted 4. Possibly due to an ARP lookup, or possibly the VPN coming up. Let's just fire a ping through again. We appear, to all intents and purposes, to be on the actual local area network now. So what should we see now? We should really see a 7 and 8 for packets encrypted and decrypted. And there we go, 7 and 8. Okay, great job. What I'm going to do, just as a matter of interest, I just want to do a little quick bit of browsing. I'm going to browse to this server here, but I'm going to browse to it via its DNS name, www.int.co.uk. Interestingly, can't get there via the DNS name. Let's try it by its IP address, 172.16.11.97. No problem at all. www.int.co.uk. Let's just close that and open it again, because I don't know whether I'm getting there or not at the minute. www.int.co.uk. Ah, now I'm getting there. Right. That was interesting, wasn't it? Okay. Can I get to the external one? www.ext.co.uk. Yep, no trouble. Now that's interesting, that is. You notice I can get to the external web server from up here through the VPN. I can get to the internal web server, www.int.co.uk, through the VPN. And it's this machine up here that's doing the DNS. Okay, VPN still connected. Let's disconnect. Give it a few seconds, and the VPN is disconnected. Okay, just so as you can see the commands that we put in, just very quickly go through the show running configuration. And what do we have? We had AAA new model, AAA authentication login, remote, going back to the local username and password database, and this is just a name. AAA authorization remote, network remote, again going back to the local username and password database. In this case we were using the user VPN with secret password of super secure. Of course I could have used any of the other users on the system, because they're all being referenced via the local username and password database. We have a crypto ISOCAMP policy. We're using, for our encryption, the advanced encryption standard, 256-bit key strength. For integrity checking, we're using the MD5 sums. For authentication, we're using the appreciated key. We're using a Diffie-Hellman group 2 and setting the lifetime to 21,600 seconds. We have a group of remote with a key of Cisco and a pool of my pool. This reflects back to the IP local pool. And for our phase 2, we have the transform set is ESP AES 256 and ESP MD5 HMAC. We have a dynamic map which locks back to the transform set. We have reverse route injection, and finally we have 4 crypto commands on here. Going back for the authentication list to remote, the authorization list to remote, the client configuration address response, and finally the dynamic map, mapping back to the dynamic map. It's a rare old configuration, isn't it, to get a VPN working. And there's our local pool. Okay. The interesting thing is, if I open the VPN up again, we should get the next address in the pool. Let's give it a try. Group, remote, key, Cisco, endpoint of the VPN, fast Ethernet 01 IP address on the router, 72 44 20 14. User, VPN, password, super, secure. And if this works, we should get 151. The VPN is connected. That was quick. Ah, there you go. 172.16.10 151. Okay. And that is that. I hope that's been a useful video for you. A lot more complicated, that one. It's quite advanced stuff, actually, remote access VPNs. We'll have a little look at IPSec LAN-to-LAN VPNs in a little while. And we'll also have a look at setting up voice over IP, get telephony working on the network. Thank you very much, and tune in for video number 7.